Welcome back to episode 8 of DApp development using Ink smart contracts on SES. In this episode, we will learn how to set up our system for developing Ink smart contracts and understand the contract code using a sample Flipper smart contract as an example. We will also deploy it on the SES chain and interact with our contract. This episode assumes that you have at least some understanding of Ink smart contracts and a basic understanding of programming in Rust. If you are not familiar with Ink and the Rust programming language, I strongly recommend gaining some basic understanding of these programming languages. Why choose Ink Smart Contract? Let's explore why you should choose Ink Smart Contract to develop your DApps. Ink Smart Contracts offer a compelling choice for developers building on the SES network. By utilizing Ink, developers gain seamless access into the Polkadot ecosystem as well, allowing them to tap into an extensive network of resources and interconnected blockchains. This access provides a robust foundation for creating scalable and interoperable decentralized applications. One of the key technical advantages of Ink is its WebAssembly WASM capabilities. Ink compiles to WASM, a universal standard supported by numerous blockchains. This compatibility enables cross-chain deployment, allowing developers to expand their DApps beyond SES and interact with other blockchain networks effortlessly. Security is a top priority for any smart contract platform, and Ink delivers enhanced security through its use of the Rust programming language. Rust's strong safety features help minimize common smart contract vulnerabilities, ensuring that DApps are secure and reliable. Ink also offers a developer-friendly environment, equipped with comprehensive tooling, extensive documentation, and active community support. This ecosystem attracts a wide pool of developers, fostering innovation and collaboration. The accessibility and ease of use provided by Ink make it an appealing choice for both new and experienced developers. Performance and efficiency are critical factors in smart contract execution, and Ink excels in this area. It ensures high performance and efficient execution of smart contracts on SES, optimizing resource usage and enhancing user experience. Moreover, Ink supports advanced features, such as upgradable contracts and a modular design. These features allow developers to build flexible and maintainable DApps, enabling continuous improvement and adaptation to changing requirements. Overall, Ink Smart Contracts provide a comprehensive and powerful solution for developing secure, efficient, and versatile DApps on the SES network, making them an ideal choice for developers looking to leverage cutting-edge blockchain technology. Ink Smart Contract Dev Prerequisites. We're going to look into a simple Flipper Ink Smart Contract and understand its structure. To get started with the Flipper project, we first need to download some prerequisites. To be able to build our smart contract, open up your terminal and execute curl https://sh.rustup.rs-s uppercase s lowercase f, then a pipe symbol, space sh. Then select one to proceed with installation. Next, we need to install Rust src component. The Rust src component refers to the source code of the Rust standard library that allows developers to access the source code of the Rust standard library, which is typically not included by default in the Rust installations. To install the Rust src component, make sure to open a new terminal or source Rust directory. Now execute rustup component, add Rust src. Now we can install the Cargo Contract tool. This tool helps in managing Ink Smart Contracts. It simplifies the process of creating, building, testing, and deploying Ink Smart Contracts. To install it, execute cargo install force lock cargo contract. This will take a while to install, so I'll be back once the installation is complete. Now that we have our prerequisites installed, we are ready to create our Flipper contract. To create the contract, execute cargo contract new Flipper, and open the Flipper project in your favorite text editor. You will notice lib.rs, cargo.toml, and .gitignore files within the Flipper project. The lib.rs file contains the source code of our smart contract, and the cargo.toml contains the Rust dependencies and Ink configuration. Let's take a look at the structure of the smart contract. This contract is designed to do something quite straightforward. It flips a Boolean value from true to false and vice versa. Simple, right? Well, simplicity is often concealed with a wealth of complexity under the hood. The contract is structured with a set of micros and functions that define its behavior and interactions. Let's take a look at the key components. At the top of your lib.rs file, you will notice config_attr and Ink contract macros. The config_attr is a Rust attribute that conditionally configures attributes. In this case, it configures the project to be no std or no standard library and no main for non-main function execution. The Ink contract macro marks the beginning of the Ink smart contract module, marking our Flipper module as the Ink contract. Within the module, you will see the Ink storage macro. This macro is used in Ink smart contracts to specify the storage layout of the contract. In the context of Substrate and Ink, storage refers to this persistent data that is stored on the blockchain and associated with the smart contract. In our Flipper contract, the macro defines the storage of a contract, specifying a Boolean value that stores either true or false. The IMPL block consists of functions that are specific to the Flipper contract. The new and the new default functions are constructors that initialize a contract with specified or default Boolean values. Those functions are marked with the in-Ink constructor macro, which is used to indicate functions that serve as constructors for the smart contract. Constructors are special functions that execute when a new instance of a smart contract is created. They initialize the state variables or perform any necessary setup when a new contract instance is deployed on the blockchain. The smart contract has two message functions marked with the Ink message macro, flip and get. These functions are responsible for flipping the Boolean values and retrieving the current Boolean value respectively. Ink message functions define the external interface for the smart contract, which represents an action that external entities can invoke. They can modify the contract state, read data, or perform any other computations. One thing to note here is that every Ink contract is required to contain exactly one storage structure, at least one constructor, and a message function. Test module. Now let's take a look at the unit test of the test macro attribute. This macro indicates that these tests are only compiled when running tests. The Ink test macro designates these as Ink unit tests, verifying the functionality of the Flipper contract. The end-to-end tests or E-to-E tests are tagged with the test feature E-to-E test attribute, indicating that they are only compiled when both the standard test and the specific E2 test features are enabled. The test uses the Ink E2E crate to conduct end-to-end testing, simulating interactions with the Flipper contract in a controlled environment. In summary, the Ink smart contract demonstrates the power of Ink embedded domain-specific language, or EDSL, that allows developers to create robust and efficient smart contracts with a clear and concise Rust code. The combination of storage definitions, message functions, and testing frameworks ensure that the contract behaves as expected in various scenarios, whether you are flipping Booleans or building complex decentralized applications. Ink provides a solid foundation for substrate-based contract development. As we explore the world of Ink, we will uncover more functionalities and best practices for creating impactful blockchain solutions. Now that you have a basic understanding of the Ink smart contract, in the next session, we will learn to create and deploy our Ink smart contracts on CES.